What I want to talk to you about today is I want to talk about makerspace, and I want to talk about the Internet of Things and how that's working with makerspace. And so we're going to do some stuff with a, let me do this real quick. So I'm going to talk a little bit about what we're doing at UVU in terms of innovation spaces and various other things. And I'm going to bring up a presentation, and there's going to be a lot of words on the presentation. I don't expect you to read everything, and I'm certainly not going to read everything either. But the purpose of it is that a lot of this, what I'm going to show you, is just generic stuff you can get off the internet about just kind of definitional. When we say Internet of Things, what are we talking about? When we say makerspace, what are we talking about? And then really where the merger of these two things are happening, and we'll show you some of the stuff that's going on in this space. So first off, just very quickly, when somebody says makerspace, what do you think of? What do you think of? Yeah.
Like 3D printing?
3D printing, great example. 3D printing, why 3D printing?
Because you're taking basically raw materials and you're turning them into an object of some sort.
Good. So you're taking really an idea, right? Creating a design and then actually creating a prototype. Okay, great example of it. Anybody else? Yeah.
Local knowledge resources, people to ask when you don't understand how to take your project to whatever next stage you're at.
Okay, and so why would a makerspace be helpful for that?
People who have either done it before themselves or who are professionally employed doing this sort of thing and are sharing that information in their free time.
Okay.
People who know what they're doing.
So a collaborative space.
Yes.
So you've got all this collaborative space that's available to use. What else? What else are you thinking of? Anybody else? When you think of makerspace? Yeah, Peter?
I think rapid product iterations, low-cost iterations, where you can rapidly create things and test them without much expenses.
Okay, excellent. So, and I think all of those are really good definitions of the type of things we're talking about. Let's see if we can get this up. Perfect. And so when we talk about makerspace, all the stuff you just brought up, great definitions of it, right? Great definitions. So you look up here, and what I did was I threw some definitions together, and these basically are coming from Google, Wikipedia, Accenture, other places like that. I'm kind of combining everything together to talk about this. But makerspaces really deal with a couple of key things. They create sandboxes. Right, what we call sandboxes here at UVU. So sandboxes are, if you think about when you were a kid, you had a sandbox, right? You went in the sandbox and what did you do? You made things, right? And the only limitation on what you made in the sandbox was really your imagination. You could do all kinds of things there. And so we think of, at UVU, we think in terms of sandboxes, and then we put tools in the sandboxes, we call them toys, right? So we put toys in the sandbox, and then we let the faculty and the students play. And that's really what makerspace is. It's about creating space, providing tools, making it collaborative, and then having people bring ideas and concepts and then see what other people are doing, combining those together, and then having the tools in place to actually create something physical out of those ideas. And it's a really cool concept, and we really do a lot of it here. So we just added $1 million 3D prototyping lab. We have Stratasys as our major partner. We have a bunch of 3D printers in there. We have an innovation center that actually works with students. So we have a student named Tanner Whedon at UVU who is a Stanford Innovation Fellow. He's one of 5 in the country right now. Stanford NSF put this program together, and Tanner has developed an innovation pathway that we're now teaching students to use this methodology for our problem identification, problem solving in a collaborative makerspace environment. So basically, you look at that. We got everything from basic space all the way through software tools, computers, 3D printers, in a lot of cases, we'll actually have manufacturing. So our new advanced manufacturing lab is actually going to have manufacturing quality equipment in it. We'll have a plastic extrusion press, we'll have a bunch of you know, stuff that can work with composites and various other things, so that you as the community can come together in there as well. It's not just UVU students, but we want to open it up to the community as much as we can. So how do they work? Well, we already talked about this, right? So they open for informal, unscheduled activity. So we do want people to come in and see what's going on. We do want people to come in and ask about things. We do want shared and collaborative space. Now, for a lot of people, that's difficult because people go, this is my toy in the sandbox, and I'm just going to play in my little corner of the sandbox, and everybody needs to leave me alone. That's great, but that's not what makerspace is for. All right, that you can go do that in your garage, you can go do that wherever. But if you want to use makerspace, part of it is that you've got to be open to explaining to people who come in what your idea is. And be able to do that. And I really like that part of it, because I know as a developer, as an inventor, you know, as a business owner, if I'm thinking something through, and I have someone who comes in and goes, look, I have no idea what you're doing, to explain this to me. It requires me to stop and really think about, what am I doing? And if the person's sitting there going, okay, I listened to you for 20 minutes and I have no idea what you just said, then I know I have a problem. Because how am I going to sell that product to someone if the person in front of me has absolutely no idea what I'm doing? So it's a really good way for people to vet through their ideas. We talked about different for design and construction. The third definition is really one that's an academic definition about how we do makerspaces on academic campuses. And then the last one talks about communities, and we're seeing more and more community makerspace. I have a lot of people, probably 5 or 6 just in the last 6 months, who have talked to me about creating makerspaces in Provo and Lehigh and in different areas, about how do we get all these people with all these great ideas together to talk about what they're doing. So the next question then obviously becomes, well, what is the Internet of Things, right? So sorry about the slides not lining up, but what I gave you was 3 different definitions here. One, like I said, you can go get these off the internet, and hopefully Peter will be posting the presentation so people can see them. But basically, Google talks about proposed development of the internet in which every object has network connectivity, right? Wikipedia describes it as a network of physical objects. And then Accenture talks about the industrial Internet of Things, the network of physical objects, systems, platforms, and applications that contain embedded technology to communicate. Right? So the real components here are this idea of the Internet of Things, or these physical objects that are interconnected. Right? And you've heard the speakers so far talk about this interconnectivity and what's there, and there's a lot of components to this, but it really boils down to these sensors, because this isn't about trying to get a washing machine to tell you that the clothes are dry. Washing machines can do that. Right? My daughter goes to BYU. When she puts her clothes in the washing machine, that when they're done, the washing machine texts her and tells her that the clothes are finished. Then she can go out and change it. People go, wow, Internet of Things. Not really. Okay, that's just a smart washer. Right? It can do a text. Now, if the washer can figure out how to align with the dryers and the other washers in the room, and they can line up with the electricity that's being put into the buildings, and so the washers are sequencing themselves so that there's no spikes in electricity, and the water is being used properly so that there's no spikes in water usage, and they can all align and do that, now you're into the Internet of Things. Right? So there is a difference here when we talk about Internet of Things versus just smart objects. A smart object is something that you relate to, and it's a one-on-one situation. A smart or Internet of Things object is something that can interface with a lot of different things. So think of it as like kind of a many-to-many relationship in terms of the things that they can do. Now, they may not be doing many different types of communication. They may only be doing one. And in most cases, that's exact. They're designed to do one. The individual sensors are designed to do one. But you may have multiple sensors on a device. So you go, like for Accenture's definition on industry, if you go to some of that, we have CNC machines, we have intelligent shop floor controls and various other things where you may have 100 sensors on a machine. We own a Peterbilt semi-truck as part of our auto program. There are 3,600 sensors on the engine alone, brand new. Peterbilt just built it and sent it to us. But it has 3,600 sensors on the engine alone. When you turn the key, the engine doesn't start, okay? You turn the key and there's about a 2-second pause, and then the engine fires up. Well, what's happening is when you turn that key, the engine wakes up. It checks all of those sensors, and then it turns itself on. Right? And it's a really interesting concept of how that works versus the old days. I don't know about y'all, I used to drive trucks. And the old days, you get in a truck, you slam the gas pedal down 5 or 6 times, you turn the key and you hope the diesel engine starts up. Big billow of black smoke, lots of noise, and the truck is awake. Right? This truck, it doesn't. You turn the key, very quiet, takes 2 seconds, next thing you know, the engine's running. You don't hear much, you don't smell anything, because those sensors are checking air pressure, humidity, temperature. They're checking where the truck is. They're checking all kinds of things before the truck actually turns itself on. Now, in those particular cases, it's not going anywhere else except to the central control module of the truck. But that is an Internet of Things connectivity. That is what we're talking about. And so we take these things and we break them out. So things in the Internet of Things sense can refer to just about anything. And I gave you just a quick list. You heard the list this morning of all the places where sensors can be applied. But this idea of everything from smart thermostats to sprinkler heads that can sense the ground, those are all great things. Most all of these on this list exist today. Right? What we're doing now is connecting them all together so that they make sense. And so we've got all of those components. So the next thing is then, well, what are we talking about then if you combine the two together? So if you take makerspace and you combine it with the Internet of Things, what you end up with are what are called innovation centers. And just to give you an idea of how fast this is growing, 38% of 200 of the largest companies by revenue across multiple sectors, so this isn't just one area, tech sector, or anything else. This is taking 200 of the biggest companies in the United States across multiple industry sectors, right? 38% of that 200 already have created innovation centers. If you go up to Lehigh, you'll see a 5-story building for Vivint. That's the Vivint Innovation Center, right? So we're seeing more and more of these get created. The digital innovation centers consist of teams of people, physical sites that are set up by organizations in what's called a global tech hub, right? So the idea is to leverage the ecosystems of startups, venture capitalists, accelerators, vendors, academic institutions, and then bring everybody in to really look at innovation and really look at products, look at services. This is not about iterative improvement, and I can't emphasize that enough. If the goal is to simply sit there and say, well, we have a product, how do we make it incrementally better than the current product? How do we get to version 2? Then that is misusing an innovation center. That is not what they are for. Innovation centers are really designed so that we can look at things and go, okay, we have a market for energy in the United States. Fossil fuels will no longer be acceptable. What options are out there? And it's a blank sheet of paper exercise. You don't go, well, I can build a better windmill. That's awesome. I'm all for that. That's fantastic. Right? I can get another 2% out of a solar panel. 2% efficiency out of a photovoltaic. That's great. That's awesome. That's fantastic. We got 1 million people on the planet working on that. What I want to know is, you know what? We got a whole bunch of people that walk on sidewalks every day. That pounding on those sidewalks can be turned into energy. How do we connect sensors to those sidewalks so that every step you take generates energy that runs the building that you're walking in front of? Now we're on to something. Right? Now we've got some interesting things. Great, one of my favorite examples, won the XPRIZE. This gentleman was serving a mission in Africa, and one of the problems was the village needed water. The village that they were working with, women were walking, and it was primarily women. They were walking a mile or more to get water and carrying it back to the village. Well, the thing was, they could drill a well, but the problem with drilling a well was they had no way of continually pumping the water. Right? And if you know anything about pumps, if you don't prime a pump, You know, if you just let it sit there, if you don't prime the pump, it won't pump, right? Well, he was in the village doing this and was going, okay, this is a huge problem, we need to solve this problem. And he's watching the kids play. And he's watching them play and, you know, run around in circles and, you know, doing what kids normally do. And he said, you know, I think I have a solution to this. So what he did was he shipped, they dug the well, but he shipped a roundabout. You know what a roundabout is for kids? You know, the thing that just spins around and around and around. Kids love these things. Adults hate them, right? So for us, we throw up. For kids, they play, right? Over and over and over again. And so he took the roundabout, he put it on the top of the well, on the pump, on a mechanical pump, and told the kids, go play. And they built a 500-gallon tank above where they were playing and ran a pipe up to it. Well, what happened? The kids played. What happened to the water? It filled the tank, right? And all of a sudden, they now had running water in the village. So he won a $1 million XPRIZE for coming up with that idea, and they're doing it all over Africa right now. Now, for us, we look at that and we go, well, that's great. You know, it works in a village in Africa. Well, why can't it work here? What makes it different here? And we go, oh, we got all this. We already have all the technology that can do that. You're thinking iteratively. For innovation, you have to think disruptive. And so innovation spaces are designed for people to think disruptively. And so we talk about all these different components that are in there, all the different things we do. We talk about what are the toys in the sandbox, right? Big data, mobile, 3D printing, robotics, social media, augmented reality. All of these things are in there so that we can go play with the toys. And we can figure out what we can do. I will tell you that since we've done this, we've been doing this for about 3 years now at UVU, I'm stunned at what the kids come up with. It's literally like Christmas in July. Right? We give them the toys, we give them the sandboxes, and they create things that I just sit there and go, okay, I'm over. I'll admit it. Right? Because they come up with stuff that's just so incredibly cool. What's really neat is when we bring in the high school kids and the 8th graders, the junior high kids, and then my students sit there and go, wow, we're old. They come up with all kinds of stuff again. The perspectives and the things are just extraordinary that they come up with. And innovation centers are designed to capture that creativity, to capture that disruptive. All right, so what can stop it? Well, we talked about it earlier. You're going to hear it all day today, right? This is Google's comment, and I like this one because I think it's really cool. If one thing can prevent the Internet of Things from transforming the way we live and work, it will be the breakdown in security, right? We have to address the security problems, but we have not everything, and you heard this morning, you're going to hear it again. Not everything needs to have the same level of security, right? If somebody hacks the sprinkler system at my house, the water runs until I get home. And you go, oh, that could be horrible. What if they did 1 million homes? Well, I think if they did 1 million homes, somebody would know pretty quick, right? Especially if we have sensors in the water system itself that's going to sit there and go, wait a minute, you know, this guy uses 5,000 gallons of water a month. He's up to 1,000 gallons for today. You know? Or more importantly, they're going to go, his average usage over time, and every second is measured, is this, and all of a sudden they see it jump, they'll just go, you know what, let's slow the water flow down there. Let's send a text message to the homeowner. Let's see what's going on. Because all of this is Internet of Things. All of this can be done. You don't need a human being to get involved in this. The system itself will do it. And so it talks to each other about what goes on and makes these things happen. So security, yes, it's the biggest issue because, you know, if you hack something and people go, well, I'm not safe, they're not going to use it. And I fully understand that. But properly using security, properly applying it at the level it needs to be applied is what we need to do. And so in closing, I want to give you that. And then the last thing I'm going to give you, because this is only 20 minutes, is this link to modularity and the Internet of Things. It's the TEDx talk that I gave in April. And it talks about ecosystems. Because the reality is innovation centers are one part of the ecosystem that needs to be developed around the Internet of Things. And so I would encourage you to go look at that talk. Take a look at it. If you have any questions, be sure and email me or call me or text me or, you know, IM me or all the other ways that you can get hold of a human being today. So thank you very much. I appreciate it.
All right, thank you, Dean Savoie. Do we have any questions from anyone?
Yeah.
The Innovation Center here at the college, is it open to the public, or do you have to be a student, or how do you?
Right now, you have to be a student to get access. You can access it through the dean's office. All you gotta do is contact me, right? But right now, it's only, because of limited space, it's only open to students. We're actually gonna we're building right now a new innovation center in the college that'll open probably late summer, start of the fall. And then the other thing I'm really excited about is that most of you are aware, UVU bought 250 acres over in Vineyards. And one of the things we're looking over there is to set aside about 35 acres just for an innovation center. So it'll be enormous. Yeah, it'll be really nice. So great question. But yeah, just contact me and we can talk about what your needs are. Any questions?
What about the SBDC innovations? Is it the same thing or is it different?
There's a couple of different things here. So you have what Peter and them are doing with the Business Resource Center in the SBDC. The Rapid Development Center that was over there has now been relocated into the Innovation Center in my college. So that's now over with us. So, and that's part of this new Innovation Center that's being developed. Anything else? Cool, thank you very much, appreciate it.